In this video, we're going to discuss a technique known as the inverse normal calculations. Now, you may recall that in probability questions related to the normal probability distribution, we usually start with the given x value, and then we convert it to z, and then we determine the probability relying on the statistical table. So if we outline the steps known as direct normal calculations, you start with the given x value, and then you convert it to z, and then you find the probability value. Now, there are some questions that require these steps to be reversed. Now, what would be the situation where you need to perform these steps backwards? Well, imagine if you do know the probability value, but you need to figure out x. So in this case, you reverse the steps so that you start with the given probability value, you look up the z value in the chart, and then you convert z to x. So how do we convert z to x? If you recall the formula for the z-score that relates x and mu and sigma to the z value, then you can solve for another variable, you can solve for x, and you obtain a new formula that relates mu and z and sigma to the x variable. So the expression is going to be mu plus z multiplied by sigma, okay? So once again, just to outline the steps of the inverse normal calculations, you start with the area to the left. So you start with the left portion of the distribution. You look up the z value in the chart, and then you convert the z value to x. Let's demonstrate this with an example. So what you want to do is make sure that you read the problem, maybe pause the video, and then we'll solve this together. So the variable x represents the time per call, and this variable is normally distributed with the average of 8.21 minutes, and standard deviation of 2.14 minutes. So let's summarize these data. So x is normally distributed with the average of 8.21 and sigma equal to 2.14. Now let's make sure we understand the question. Now, in these type of questions, I recommend the use of the graph. So if you use the graph, it will help you understand the question. Let's draw a distribution. So here's our bell-shaped distribution with the average of 8.21. Now, we need to find the x value that represents the time limit such that only 10% of all phone calls will exceed that time limit. So what happens if the time is being exceeded? Well, in that case, the operator will hear a sound in her system alerting her that she exceeded the time of the call. So what is that time limit that we need to find? So first of all, let's make sure we understand where that value belongs in the graph. Is it to the left of the mean or is it to the right of the mean? So think about this. Only 10% of the calls should exceed the unknown time limit. So this suggests the unknown x value is above the mean, so that 10% of the phone calls exceed this unknown x value. So this right tail of the distribution represents 10% of the data. And so x is not known. So what this tells you is that there is 90% of the distribution below the unknown x value. And we're going to rely on this value, 90%, to look up the z-score in the table. Let's go ahead and do this. So we're going to look for 90% probability inside the table. So remember, these are the probability values inside the table. These are the probability values, and we need to find the value as close as possible to 0.9. So we're looking for 0.9, but we may not be able to find that value exactly, but we're looking for the closest match, such as this value over here. This is pretty close to what we're looking for, 0.8997. It's pretty close to 0.9. And then we read the z-value of the chart. So if we go back to the z-score, then the z-score from the table is 1.28. Now we're going to convert it to x. So let's go ahead and record the z-value. So the z-score we found is 1.28, and we're going to convert it to x. The formula to find the x value is mu plus z times sigma. We plug in the average, 8.21. We plug in the z-value, 1.28, and we multiply it by 2.14. So multiplication will be done first and then addition. And you should get the result of 10.95 if we round to 2 decimals. So what units should we use? Minutes, okay? So the time limit should be close to 11 minutes. So if an operator exceeds this time limit, she will hear a sound alerting her that she's taking a little too long with the customer, and then maybe there are some other customers being put on hold. All right, so I hope you find this helpful, and then we'll continue with other concepts and examples in the next video. Talk to you soon.